Welcome a manifold vector creation for different configurations. Now, we will be talking some more example from the 3-dimension point of view. At the same time, we will also be seeing what happens when I plug in the Rx side also. So, this will be the last example from the Tx side. So, some of the things that we will be covering. So, let us say I have z, y and x angle, these are the coordinates. So, this is completely Tx side and my antennas are something like that. So, this is my first antenna, let us say that is my reference point, my second antenna, this is my third antenna and this is my fourth antenna, which is a UPA, but I make a small modification. I assume that there are here, so probably I will put it this way. Something like that. So, which means that there are antennas like this, one antenna here, one antenna here, one antenna here and one antenna here. Okay. So, basically you can think this is more of a 3-dimension kind of things. So, let me just try to join it, see if I can create some sort of a shape here. Yeah. So, this is in a box my antennas are there. So, this is 3D configuration. So, how can I, so this is my Tx side, this is how my antennas are there. So, how can I create the array manifold vector? So, let us assume that this is my reference point. Okay. So, here just it is an extension of what we have learned, it is just that now the antennas will have x, y, z. Some of the antennas will have x, y and z all non-zero. For example, this particular antenna will have x, y and z non-zero. Yeah, so this is one such antenna. So, rest of them at least one or two elements can be 0. So, now so if I just take any one of them antenna, so let us take this particular antenna. So, okay, so what it would be? So, let us say it's got so let us say everything is equally spaced. So, the position of this particular antenna is D, D and D, right. You can for rest of the antennas what are the different coordinates there, right. So, what is my array manifold vector? So, how many elements in the array manifold vector should be there? There are 8, because there are 8 antennas are there. So, A bar T will have 8 component. Okay. So, probably this would be if I start from here, this is 1, 2, 3, 4, or this is 5, 6, 7, 8. This is how say I am just proceeding. This is how the numbering says that that's the point where it is the feed is touching, that is the order of touching the feeds electrical signal. So, that means it is for touching here first, then second, then third, then fourth, and then it goes to fifth. And in fact, you can, if you are not so comfortable, you can change the coordinates here where it is touching it here. You can say from 1, then it is touching 2, then it is touching 3, 4, then this can be my fifth, this can be my sixth, this can be my seventh, this can be my 8. Yeah. So, that is the order in which the wiring is touching. I mean, it is touching first here, then it goes to 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 here, and so on and so forth. So, that is the order in which it is. So, I am talking of the sixth one. So, probably the 1, 2, 3, 4, 5, 6, 7 and 8. 8 position will be there. For the first position it is 1 because that is from there it is distributed. So, I am talking of the 6th one, which is the one that is the most complex, that is not complex, but that has all the components. Rest of them will be at least easy, you know how to do it. For this one it will be the j into 2 pi by lambda multiplied by d, you can take it common, okay, because that is the coordinate is d d d d. 3 d's will be there. So, this would be sin theta cos phi plus sin theta sin phi plus cos theta. That is the term will be coming there, and for rest you can calculate. Okay. Got it? So, this is kind of a generic. Now, I can even further make it generic. What if the distances I can tweak it. Okay. So, if you understand how to do it, how to create the Allen manifold vectors from either transmitter receiver side, that is it. So, it does not really matter where my antennas are there, but you have to be very careful where the reference point is, because from the reference point and then the order of numbering. Why the order of numbering is important? Because that shows in which order the electrical line is actually distributed. So, that means when I say the R is my first order, then I say this is my second order, it means that from there the electrical line actually goes to the second antenna, from there it goes to the third antenna, from there it goes to the fourth antenna, and so on and so forth. So, the way the electrical wiring is present, you have to number it in that order, because that is the phase difference it is creating. Okay. So, you cannot say this is my first, this is my second, this will not work out. Okay. So, that ordering is important. Of course, that ordering has to be given to you, otherwise that Allen manifold product cannot be generated. Okay. So, now let us go to the RX side. Now, I am little relaxed from the RX side because I do not have to say anything extra from the RX side. Why? It is the same as TX side, just that in the TX side it was an angle of departure, now in the RX side it will be angle of arrival, but concept remains the same. So, which means that same thing, this is my RX side, suppose I have my RX antennas like that, and the rays can come at any direction, but I am considering because it is an RX, right. So, here angle of arrival is what matters to me. So, let us say my angle of arrival is theta phi. This is the direction at my angle of arrival is coming. Okay. How do I create the AR or the array manifold vector at the receiver side? Again the same concept, whatever you have learnt in the TX side, same thing you can extend it, just that only difference is that instead of angle of departure, now you have to take angle of arrival side. Now, here angle of arrival side means theta r and phi r. Now, for the benefit of lot of notational issues, I may drop the r just to understand, but you can continue the r notation. So, what is my AR? So, let us say this is my reference point, this is my first antenna, this is my first reference antenna, this is the second antenna, and probably this is my third antenna, this is my fourth antenna. Okay. How the AR will be constructed? This is the first antenna will be again 1, second antenna let us call it xi r1 e to the power j xi r2. I hope this does not require much explanation of how you can find out the xi, each and individual xi. So, how do you find out? Let us say I am drawing only for the third one, last one. So, how do I create this xi? So, this should be again the same formula 2 pi by lambda. So, that is the angle that it will be seeing. So, that is the angular differences it will be seeing multiplied by 2 pi by lambda multiplied by the coordinates. So, what is the coordinate for this gentleman? This would be 3D 0 0. I am talking of this gentleman, right. So, this should be 3D and this is the z part. So, I am making little mistakes here. So, as it is in the z direction, so it will be 0 0 3D. Okay. So, this should be 3D multiplied by as you know the direction vector remains the same. So, it is the same as what we have drawn earlier. So, this will be cos theta. Now, if I have other combinations like whatever combinations I have drawn, in the T x, same thing will be applied here, except that the angles will now be referred as a angle of arrival. Now, what if I have multiple such reflectors? What would be the case? Okay. So, let us take that also. Let us say I have in the R x side, I have two antennas. So, this is my z, this is my x, this is my y. But now, I am saying that this particular system has two reflectors. So, which means that I may have one reflector here, I may have one reflector here. Okay. How do I do that? Now, as you know, when you have multiple reflectors, for the multiple reflectors, you have multiple angle of arrival and obviously multiple angle of departure, because there may be a antenna system here, but these reflectors, the way he receives it and the way he receives it, it will have one set of angle of departure, and the way he transmits it and the way he transmits it, it will have another angle of arrival here, right. So, there are two different, it is as if like two systems are coming, right. So, how do I, it means that for this particular case, I have to know for each individual angle of arrival and angle of departure, then only I can construct that. I mean, you know the channel models there, right. So, it was summation of alpha I a I r a t I vector, right. So, now this is I. So, it is no longer just one constant angle of arrival and angle of departure, it depends on how the reflectors, where the reflectors are. So, now concept remains the same, it is just that it will have, in this particular case, it will have two angle of two array manifold vectors from the transmitter side and two array manifold vectors from the receiver side. That is it. Okay. So, this does not change my complete configuration, it is just that it is an extension of it. Now, I hope you can extend it such kind of problems. If I say in the exam, if I give you, okay, this particular configuration has these are the angle of arrival, these are the angle of departure for two cases. I hope you can construct the angle of arrival and angle of manifold vectors for transmitter side and receiver side, right, because you know all the parameters. So, it is just matter of recreating the things. Okay. So, now let us combine it, that is what we want. We want AIR, AIT, we want to find it out separately and then we want to combine it, so that we can construct my H. So, let us take a simple example. Let us say my transmitter side has configuration like this. Four antenna the z direction, whereas my receiver has configuration only in the x side and that too only 3. This is my transmitter side, this is my receiver side. Okay. This is my receiver side, but mind it, in the receiver side all my antennas in the x direction and there are only 3 antennas, and in the transmit, now I am combining it, okay, because this view should be important to you, how exactly in a real system they work. Okay. Now, there is a polarization problem and so on and so forth that will come into picture, but let us not get into that first. We just want to construct my manifold vectors and all. So, here, so what is my final channel? My final channel will be H into, it is a H matrix, right. So, what is the dimension? So, it is as if like there are 4 antenna from transmitter, there are 3 antenna at the receiver, but this is what the physical dimension. Okay. Just close your eye and try to visualize what exactly the scenarios. One in the transmitter side I have z direction 4 antennas, but in the receiver side my antennas are all in the x side direction. So, I want to finally create my channel here. Okay. Let us not worry about my reflectors and all, let us say it is a simple reflectors. So, in this particular case probably I can just introduce one, just to make my problem slightly complicated. Let us say I have only one reflector, because otherwise I cannot make my angle of arrival and angle of departure separate, just to that. So, let us say this is where the rays go from transmitter side, this is where my rays comes in the receiver side. This is how it is. Okay, just to make my understanding slightly better. Okay, and there is no other reflector. Okay, so here why do I do that? Because here I just want to make sure my angle of arrival and my angle of departure are separate. Otherwise, I have to make my angle of arrival and departure both same, because the direction at which I am sending and the direction at which I am receiving, and I do not see any difference. So, I have just created a reflector so that that path is. So, I have theta t and phi t, and here I have theta r and phi r. That is what I have given. So, under this scenario I want to construct my channel here. Okay. So, what is given? AOD given. What is given? AOA is also given. Okay. 4 antennas in the z direction, 3 antenna in the x direction for the RX. So, I want to construct my H. So, what is the dimension of H? That you should understand. What is the dimension of H? The dimension of H will be NR cross NT. So, which will be it is simply a 3 cross 4 vector matrix. Okay. So, which means my AR or receive manifold vector is a 3 cross 1 and transmit manifold vector is a 4 cross 1. That is all. So, which means as there is only one reflector, the only thing I know is H is equal to, now there should be a gain. So, let us assume that generalized gain is alpha. I do not want to get into the gain problem here. Now, this AR I need to construct, which is a 3 cross 1, there is a T here, and then this would be my AT vector, which is a transmit manifold vector or transmitter side manifold vector, and that is 1 cross 4. That is the only thing I need to make it. Now, this is T as a whole. So, this should be 1 cross 3 only, but just as a transpose is there. So, this is what my job is. So, individually I now need to create this one and I need to create this one. Okay. Now, if it is an AR, how do I create it? Now, let us form AR vector. It is in the x direction. Okay. Let us see the distance among them is d1, d1. I try to make it slightly different, which is more practical. Let us say this is d2, this is d2, this is d2. That means distance among the distance between two consecutive antenna is d2 in the transmitter side, but d1 in the receiver side. There is no such relationship that you have to make them all equal. There is no relationship, because I can have my own separation of antenna in the transmitter side, I can have my own separation of my antenna at the receiver side. Only thing that they have to be greater than lambda by 2. That is the only requirement. They need not be same. Okay. So, let us take a very general case. Okay. Now, I am constructing here. So, what should I do? As it is as if like I am constructing AR in my receiver side, and you know how you have already done it. Okay. So, for this is 0 0 0. So, that is simple enough. For this one, what is the coordinate? This will be d1 0 0. This will be 2 d1 0 0. So, that is the coordinate, right. Okay. Okay. So, this should be 1 e to the power j 2 pi by lambda multiplied by the coordinate of the antenna, which is this one d1 0 0. So, it will be d1, but now direction vector is what? Direction vector does not change. So, that will be cos, sorry, this should be sin theta r will be there, and cos phi r. That is the point. That is it. Nothing else will be there. the rest of the 2 points are 0, and the third point is I cannot fit everything in. The third point is e to the power j 2 pi by lambda. What is the distance here? It is 2 d1, 2 d1 sin theta r cos phi r. That is it. This is my third point. So, you see there are 3 elements. I have constructed my receive manifold vector. What about my transmit manifold vector? There are 4 points here having a distance these d2, 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 but it is in the z direction. So, it will be easier to do that. So, 1 e to the power z 2 pi by lambda d2 cos theta t e to the power j 2 pi by lambda into 2 d2, because it is the second antenna. So, distance will be 2 d2 0 0, that is the coordinate 0 0 2 d2, but this will be theta t e to the power j 2 pi by lambda 3 d2 cos theta. Note that in AT I do not need phi, that is okay, because that is how the configuration is. Now, I got 2 vectors, multiply them, you get h. So, your h will be multiply this alpha let us assume I know it, but I have somehow estimated, and then this AR vector transpose multiplied by this AT vector whatever comes. So, it will be a 2 cross 3, 2 cross 4, not 2 cross 3, it will be, or rather sorry, not 3, 3 cross 4. This will be a 3 cross 4 matrix that will come. So, this is my one vector, this is one vector, this is a second vector, right, multiplied whatever comes into picture, 3 cross 4, you can get some matrix there. So, that is my channel. That is precisely my channel. I have not done beam steering, this is just the beam forming, in the sense that I have not still defined how exactly my beam properties will be there, but that is that I will be talking definitely next, because this only shows how my channel is formed. Okay. But what is the beam characteristics, that I have not said, because this is an array processing part, that will come next. So, this is exactly my channel is formed now. So, now you can construct a channel. Suppose if somebody gives you a configuration like that, now you will be confident enough to construct a channel. So, this is my RX side. Let us say my antennas are placed like that. Four antennas. So, this is my x and this is my y coordinate. Okay. But in the RX side, let us say I have antennas which are placed only like this. This is how my RX side antennas are placed. Okay. You know how to do it, you know how to solve it. You can number it, depends on how exactly the configuration is, and you can construct your H. So, there may be quiz questions like what is the dimension of such H. So, this is how physically it will be like that. It can even be like you can put the antennas in other direction as well. What if I put my antennas like this? It is xz plane I have placed my antennas, and in the Tx side I have put it on the xy plane. So, can I construct my H? Yes, I can construct. For the first case, what is the dimension of my H? It is NR cross NT, right? So, NR is 6 and NT is 4. So, in the first case it will be 4 cross 6. For the second case, H will be 4 cross 4. Okay, and you can construct your H very easily, but only thing you have to know what is alpha, and this is with one reflectors. If I say same configuration, I have one reflector here, I have one more reflector here, construct the channel. Okay. Nothing, the same thing, you just repeat it for two summation, because for two reflectors you need a two separate set of angle of arrival and angle of departure, as simple as that. For this there is an angle of arrival and angle of departure, so angle of departure, angle of arrival with respect to the other one. So, I can say this is the angle of arrival for Tx from Tx side, this is the angle of departure from that side, and for this here is one set of angle, one set of angle here. Okay. So, that means when it is reflecting, angle of departure is acting as an angle of arrival here. For this reflector, angle of arrival is nothing but the angle of departure from the Tx side. I mean, if you can understand the concept, that's fine. Okay. So, that is it. So, this can be generalized to any concept. So, what if in the assignment somebody asks you something like that, in the Tx side my antennas are configured like that. Three dimension case, but whereas in the Rx I have say UPA. Can I construct my channel? Yes. So, what is the dimension of the channel first of all? It is just a matrix. So, let us say there is only one reflector. Okay. So, what is the dimension of this matrix? So, it is NR cross NT. So, how many NR antennas are there? 4. How many Tx antennas are there? 8. So, you will have to construct a 4 cross 8 antennas. Okay. Suppose there is no reflectors in this case. So, will it have two different set of angle of departure and angle of arrival? Suppose no reflector, it is a line of sight. That means, if there is, if at all a beam is created, the receiver is in the same path. So, what should be the angle of departure and angle of arrival in this case? Will I have two different, do I have to give you two different AOD and AOA? No. Why? Because it is directly going, maybe it is in a beam form, that is okay, but whichever direction the beam is going on the same path, this is present here. So, in this is a scenario where the direction of beam where there is no reflectors or scatterer, without it, it is just going and the reflector or the receiver is sitting inside it. So, it is as if like angle of arrival and angle of departure are all same. Or it will be a problem only if there is a reflectors, because if there is a reflectors, what will happen, this beam will be going like this, but there is a reflector, and with this reflection the beam is getting reflected in this Tx side. So, in this case the angle of departure, suppose there is only one reflector is present, and angle of arrival at the receiver will be different, because there is a reflector which changes the angle of arrival and angle of departure. But if there is no such reflector, so then what happens? The beam is going like this and my receiver is also sitting. So, whatever angle of departure he creates it, as because the receiver is also sitting in the same direction, in this case this will be equal. Okay. But in this case angle of departure, angle of arrival will be different. But these are the different scenarios. I can create it from a simulation purpose or a practical purpose. Practical is how it will be, right. You have a multiple set of AOD and AOA, but if it is an LOS transmission, it is the same AOD and AOA would be, assuming the receiver is also sitting at the same point. Okay. So, with this I hope I make you understand how exactly the H matrix can be configured or can be constructed for different configuration of my antenna at the Tx side and Rx side with 1D, 2D and 3D. Okay. This is what we have just concluded, and these are the various references. With this I conclude the talk today.